Hi, this video is on the basics of graphing inequalities. The goal is for you to graph linear inequalities in slope-intercept form. To do this, you must already know how to graph linear equations. So for example, to graph this inequality, you have to know already how to graph this equation. Okay. If you know how to graph equations, all you need to know are two additional things to graph inequalities. Okay. First, I'm going to give you the big picture. So don't worry if you don't get this yet, I'm going to explain afterwards. Okay. To graph y is less than 2x, we graph y equals 2x, but as a broken line, and we shade below. To graph y is less than or equal to 2x, we graph this equation as a solid line, and we shade below. To graph y is greater than 2x, we graph, again, this equation as a broken line, and we shade above. To graph y is greater than or equal to 2x, we graph y equals 2x as a solid line and shade above. So the big picture here is that the graphs of inequalities are these regions, and these regions have boundaries that are either lines or curves. And we have to know two things. We have to know whether the boundaries are drawn as a solid or broken line or curve. And we need to know whether the graph is above or below that line or curve. Let's first review graphs and equations in general. So what's a graph? It's a set of points. Okay? Each point is a solution to the equation or inequality. What's a solution? Solutions are numbers that make the equation or inequality true. So for example, 2 is a solution here because when we substitute, 2 makes this equation true. Here, the solution set is all numbers greater than 4 because any number larger than 4 makes this true when we substitute. So let's take this equation. We can ask when x is 1, right, what value of y makes this true? Well, x is 1, 2 times 1, y is 2. So this point, 1, 2, right, xy, makes this equation true. Therefore, it's a solution and it belongs on our graph. And we can do this for all values of x and get a line. And we should notice here that for each x value, there's exactly one y value that makes this true. Okay. Now let's consider this inequality. Y is less than or equal to 2x. Well, the equal to part, we just did that. That's a line. So y equals 2x, that's the line. Now let's consider the y is less than 2x part. Okay. Again, if x equals 1, what y values make this inequality true? Well, we know about 1, 2. What about 1, 1, and 1, 0, and 1, negative 1? All of these y values are less than 2, less than or equal to 2. Okay? And in fact, all the points below 1, 2, all these points here make this inequality true. They are solutions. So our graph then is this solid line here, all the points on this line, and all the points below the line. So to graph this, we draw a solid line and we shade below. Okay? So in general then, to graph an inequality in this form, we graph the equation first, y equals this expression. In this case, we shade below, because y values become less as we go down. Okay? For example, to graph this inequality, we graph the equation first, y equals negative 3x minus 1. Then we shade below, because y values become less as we go down. For this symbol is greater than or equal to. Again, we start with the equation, we draw that line, then we shade above, because y values become greater as we go up. Okay? Now, what about these symbols when there's no equal sign? Well, we know that when there's an equal sign, our graph is a line for linear expressions. Okay? So it makes sense then, if there's no equal sign here, then there's no line in the graph. So what that means is the graph of this inequality is the graph of this inequality, but without the line. Well, how do we show that there's no line that's part of the graph? Well, we draw a broken line or a dotted line. Okay, so for example, we notice here there's no equal sign. What that means is there's no line that's part of the graph. We indicate that with a broken line. So we graph this equation as a broken line, and we shade below. Okay? Again, the broken line means points on this line are not in the graph. Okay, again, there's no equal sign here, so no equal sign means no line. We indicate that with a broken line. In this case, y is greater than, we shade above. So the question is why? Why are points on the line not included in the graph when we have these symbols? Okay, let's consider this again. We know that the point 1, 2 is a solution. Why? Because when we substitute, it makes this an inequality true. Okay? Now let's consider y is less than 2x. Right? Is the point 1, 2 a solution? Well, let's substitute. Y is 2. Y is 2. 2 is less than 2 times 1. Is this true? Well, no. 2 is not less than 2. This is false. So the point 1, 2 is not a solution. In fact, none of the points here on this line are solutions. And the way we show that is by drawing a broken line. So our final graph then is a broken line with the region underneath shaded. Okay? So we can divide the xy plane into 3 parts. There's the line or curve, there's a region above, and then the region below. And if we combine these 2 graphs, in this case, we would get the graph of y is greater than or equal to x. And if we combine these 2 graphs, we would get the graph of y is less than or equal to x. So let's practice that. Again, this symbol, what does it mean? Well, it's a combination of these 2 symbols. So it makes sense then that the graph of this inequality is a combination of this inequality and this equation. So let's take a look. Here, no equal sign, so we indicate that with a broken line shaded below. Right? Equal sign, solid line. If we combine these 2 symbols, we get this inequality. If we combine these 2 graphs, we get this graph. Okay? Now for is greater than or equal to, this is a combination of these 2 symbols. So it makes sense then that this inequality, the graph of this inequality, right, is a combination of the graph of this inequality and this equation. So let's take a look. Greater than, no equal sign means no line, so broken line, shade above. Y equals, solid line. If we combine these 2 symbols, we get this symbol, and we combine these 2 graphs, we get this graph. Okay, so here's the big picture. The graphs of inequalities are regions. And if there's an equal sign that's part of the symbol, right, we know there's a line or curve that's part of the graph. If there's no equal sign here, then there's no line or curve that's part of the graph, which we indicate with a broken line or curve. Okay, let's review. Okay, when does a graph have a broken line or curve as its boundary? Well, when there's no equal sign. When we have only is less than or is greater than. For y is less than some expression, why do we shade below the line or curve? Well, we know that y values become less or decrease as we go down. In this case, though, in this form, it's not as obvious where to shade. So in this case, we draw the line first, and then we test a point to see where to shade. Okay. For y is greater than some expression, where do we shade in y? Well, we shade above the line or curve, because y values get larger as we go up. Okay, let's practice the reverse process. What equation or inequality is graphed here? Well, solid line, y equals x in this case. Broken line, shade above, y is greater than x. Broken line, shade below, y is less than x. Okay. So in summary, the key to graphing inequalities is really just knowing how to graph equations. Once you know that, there are just 2 more ideas. You need to know whether the boundary is solid or broken, and whether the graph is above or below that boundary. Thanks for watching.